Today, less than 1% of textile waste is recycled fiber to fiber. This low figure highlights a significant challenge in the textile industry, where issues like collection, sorting, and pre-processing limit the amount of waste that can be effectively recycled. Fiber-to-fiber recycling isn't as simple as it sounds. It requires disassembling garments and accurately identifying the different fibers they contain. But here's the problem. Clothing and textile products are rarely made from a single material. They often consist of mixed fabrics, trims, fasteners, and other components, all made from various fibers. This complexity makes recycling much more difficult. Blended fabrics, for example, contain fibers of different types that are hard to separate. Often, the exact composition of these materials is unknown, making it even harder to process them for recycling. And because each material requires a specific recycling method, having a mix of unknown fibers slows down the process and reduces efficiency. As a result, the presence of mixed materials has been one of the biggest obstacles to effective fiber-to-fiber recycling. Overcoming this challenge is key to creating a more sustainable textile industry, one where waste isn't just discarded but transformed back into valuable raw materials. The future of textile recycling depends on innovative solutions that can handle these complex materials, streamline sorting processes, and make fiber-to-fiber recycling a standard, not an exception. Mechanical recycling and chemical recycling. Textile recycling plays a crucial role in reducing environmental impact, and two key methods lead the way: mechanical recycling and chemical recycling. Mechanical recycling is the process of shredding post-consumer textile waste that can't be reused. The fibers are defibered and transformed into new materials like yarns, industrial rags, padding, fillers for the automotive industry, insulation, and non-woven carpets. This method helps reintroduce waste back into the textile value chain, creating high-value products while preserving the material's integrity. Take pure cotton recycling, for example. The waste is shredded, then compressed using heat and pressure to form new material blocks. These are used as the base for new products. Spain leads Europe in this field, producing around 61,000 tons of recycled yarn annually. Mechanical recycling has a low environmental impact. Just 1 kilogram of recycled cotton can save over 2,200 liters of water, cut energy use by 15.29 kilowatt-hours, and reduce carbon emissions by 1.73 kilograms. However, there's a challenge. Fiber quality decreases with each cycle as fibers shorten, limiting their reuse. To manage this, textiles are sorted by color and composition, like natural cotton, then shredded, cut, and defibered to become raw material. Major brands use this process to create new collections, effectively closing the loop and turning waste into valuable resources. Now let's talk about chemical recycling. Unlike mechanical methods, chemical recycling breaks down textiles at a molecular level. It uses chemical processes to convert fibers into basic components, which can then be spun into new fibers, yarns, and textiles. This process includes dissolving cellulose to make viscose fibers or depolymerizing polyester back into monomers. It even explores biorefinery techniques to extract chemicals like alcohols from textile waste. After sorting and cutting, textiles undergo chemical treatments at high temperatures, breaking fibers into their fundamental units, comparable to virgin materials. While polyester recycling is more advanced, chemical recycling of cotton and wool is gaining momentum as demand for recycled fibers grows. For example, recycling just 1 kilogram of textile waste can prevent 3.2 kilograms of CO2 emissions. Although chemical recycling is still evolving, advancements in garment composition analysis and contaminant removal are making the process more efficient. A key factor for success is the meticulous classification of textile waste by fiber type. Together, mechanical and chemical recycling are paving the way for a more sustainable textile industry, where waste isn't the end of the story, but the start of something new. In the journey toward a circular textile economy, advanced next-generation technologies are transforming how we manage textile waste. These innovations enable the automatic classification and separation of materials based on composition, color, and shape, dramatically increasing efficiency and sustainability. Technologies like smart waste systems, near-infrared, NIR, spectroscopy, and artificial intelligence, AI, with deep learning are revolutionizing the industry. They can identify and sort materials such as cotton, polyester, viscose, wool, polyamide, polyethylene, and even elastomers and acrylics. Using AI models, these systems predict fiber concentration from NIR scans, allowing both pure fibers and complex blends to be processed with precision. A standout example is FiberSort, a semi-automatic textile sorting machine powered by AI. It identifies textiles based on fiber composition and color properties, processing large quantities quickly and accurately. In fact, it can sort 1 garment per second, up to 86,400 garments a day. Considering that 1 kilogram of clothing contains around 4 garments, that's roughly 21,600 kilograms sorted daily. This efficiency helps manufacturers and recyclers adopt more sustainable business models. Supporting this process is TrimClean, a system designed to remove non-fiber components like zippers, buttons, and labels. By eliminating these trimmings, TrimClean increases the purity of recycled raw materials, ensuring high-quality outputs for fiber-to-fiber recycling. It identifies fiber content instantly and pneumatically separates unwanted materials, making the recycling process faster and more reliable. Good practices in textile recycling are being implemented across Europe and beyond. For example, TX2MAT in Austria develops techniques to separate polyester and cotton from multi-material textiles. Companies like CO and SOEX in Germany handle everything from garment collection to recycling, while the TRI Group in the UK processes over 400 million used garments annually. Another innovative company is Textile, one of Europe's leaders in sustainable textile collection and recycling. With operations in Switzerland, Germany, Austria, and the USA, Textile combines economic activity with social responsibility, recycling textiles while generating funds for charities. In Spain, the Reusem project, led by Sadico and Córdoba, promotes a culture of reuse across Mediterranean cities. Working with partners in Italy, Jordan, and Tunisia, Reusem helps communities adopt sustainable habits and reuse practices, fostering environmental awareness and social engagement. These technologies and projects are shaping the future of textile waste management, creating a world where textiles aren't just discarded, but given new life, again and again. Reuse and upcycling in the circular economy. Preparation for reuse plays a vital role. It involves checking, cleaning, or repairing products that would otherwise become waste, ensuring they're ready for reuse without the need for further processing. This process not only extends the life of products, but also reduces the demand for new resources. When it comes to textiles, reuse and recycling can preserve fibers and reduce carbon emissions by up to 98% compared to using virgin materials. However, the fast-changing world of fashion presents challenges. Consumers frequently update their wardrobes to keep up with trends, especially in the fast fashion industry, where garments are designed for short-term use and quickly discarded. This contributes significantly to textile waste and environmental degradation. In the realm of fashion, it's important to distinguish between sustainable fashion and recycled fashion. Sustainable fashion includes garments made from eco-friendly materials like organic cotton, produced with reduced water usage and non-toxic dyes. It also considers ethical factors, such as fair wages and environmentally responsible production processes. On the other hand, recycled fashion focuses on garments made from waste materials, giving new life to discarded textiles. While recycled fashion contributes to waste reduction and cleaner ecosystems, it isn't always sustainable, unless it also meets social and environmental standards. Another growing trend is upcycling, also known as supercycling. This creative approach transforms old or discarded textiles into new, higher-value items. Imagine turning an old shirt into a stylish headband or repurposing fabric scraps into unique fashion accessories. Upcycling isn't just a technique, it's a statement against overproduction and the waste generated by fast fashion. It encourages us to see potential in what we might otherwise throw away. In contrast, there's downcycling, where textiles that can't be reused are processed into lower-value products. These might include non-woven fabrics, automotive insulation, cleaning rags, or, in the worst cases, materials destined for landfills or incineration. While downcycling helps divert waste from landfills, it doesn't preserve the material's value as effectively as reuse or upcycling. Ultimately, whether through reuse, recycling, upcycling, or even downcycling, Every effort counts toward reducing textile waste and creating a more sustainable future for fashion. The key is to shift our mindset from disposable to durable, from waste to resource. Trained professionals manually assess the suitability of textiles for reuse or recycling, following the Waste Framework Directive's hierarchy. Workers comply with workplace safety rules, use personal protective equipment, and undergo health surveillance. The process begins with waste reception, weighing and unloading, followed by feeding conveyor belts for manual and mechanical sorting. A trommel separates recyclable from non-recyclable materials, while magnetic systems extract ferrous and aluminum fractions. Recyclables are compacted into bales for storage and transport, while rejected materials are disposed of. The final phase includes loading trucks for further treatment, maintenance operations, and equipment cleaning. The technical area of clothing production covers spinning, weaving, knitting, dyeing, and finishing, along with identifying and classifying textile fibers. Professionals operate sewing assembly and finishing machines, including overlockers and hemmers, with a solid understanding of patterns, cutting, and ironing. Competency levels range from basic standardized tasks, Level 1, to autonomous execution of specialized techniques, Level 2. They also contribute to product development, supervise manufacturing, and ensure quality in textile, clothing, footwear, and leather industries.